This is activity 18 for level 1 electronics, and in this activity we're going to use a transistor to control an LED. To get this activity and all of the others at level 1 electronics, visit jb.works and at the search prompt enter the TMT code shown at the bottom of your screen. If you think back a few activities ago, electronics is basically concerned with electrons moving through wires like these. And all the switch does is bring two wires together. So whether it's a key on your keyboard or a light switch or even a button on the top, they're all bringing wires together. And this is a very physical thing. I'm physically moving two wires. When I push the button on the top, I'm physically bringing two contacts together. And we did the paperclip switch a couple of activities ago, I think. And again, it was a very physical thing. The transistor, on the other hand, does exactly the same job, but it's entirely electronic. There are no moving parts, and it's a lot smaller. And this is borne out by the fact that the iPhone 12 has 12 billion of these transistors inside, the little tiny ones on integrated circuits. So what we're going to do in this activity is use one of the transistors on the top to control an LED. So when I turn the top on, immediately the LED turns on. If I disconnect the wire that's controlling the transistor, it turns off. And then if I plug it back in again, it turns on. So the wire that I'm controlling is actually the middle wire on the transistor. So if I just spread the legs apart a wee bit, so you've got 3Ds. You've got the collector, the base, and the emitter. And I'm controlling the base. So this is a very simple transistor circuit. And it's identical to this transistor here, except this is a power transistor, and it might be controlling the motor in a refrigerator or on a scooter or whatever. It's just more power. So now let's look at what we need. For this activity, we need a charged JackBord, a JackBord top, and 9 short female-to-female jumper wires. Let's have a look at the circuit. Now the first thing we have is a 3-volt power source, and that's feeding into a 1K resistor, which in turn is going into our LED. So that's basically this wire here, coming down to a 1K, going through there, round, and into the positive arrow of our LED. Then the next wire goes from the negative side of the LED into what's called the collector of the transistor. And that's this wire here. So it's going into the collector of the transistor. Next we have another 3-volt wire, which is this blue one, and that's going into another 1K resistor, which is also down here. And finally we have a jumper, which is this blue one here, that is going into the base of the transistor. And lastly, we have a green jumper that goes from the emitter of the transistor all the way down to ground. Now, secondly, the resistors are here to limit current. So this one here limits the amount of current that can flow into our LED because we don't want to blow it up. And likewise, this resistor here, which goes to the base of the transistor, limits the amount of current that can flow into the transistor, because if you have too much, you'll damage it. Now the way transistors work is that if the base is at 0 volts or below about 0.6 of a volt, the transistor is turned off. So that's equivalent to our two pieces of wire that we saw earlier not touching each other. But if you apply a voltage to the base of the transistor of about 0.6 volts or higher, it begins to conduct, or it turns on. And that's equivalent to when we were touching the two pieces of wire together. That lets the current flow. So as far as our circuit is concerned, when the transistor is turned on, it's the same as a piece of wire. And it just lets the current go all the way through here and straight down to ground, as if the transistor wasn't there. And then when the voltage on the base goes below about 0.6, all of a sudden the transistor turns off and it's as if there was nothing in here, and there's no path for the current to flow, and the LED turns off. Right, now it's time to start building the circuit. So what we'll do is we'll build it with the top off the JackBord. So we'll start with the yellow wires, and they are the 3-volt parts. So we're going to connect to this 3-volt line here, and that is going to go to our 1K resistor. And I get another yellow wire, and that goes from the other side of the 1K resistor, and it goes into the plus side of the white LED. And then finally, our third yellow wire goes from the negative side of the LED into the collector of the transistor, and you can see that at the top. So that gives us our 3 volts going into the 1K resistor, around into the LED, and then into the collector of the transistor. Next, we're going to connect the blue wire, which goes again from 3 volts into a second 1K resistor, and then it will go the other side of the 1K resistor, so we'll also use a blue wire for that. Comes out, and it goes into the base of the transistor. So we've got 3 volts going through a second 1K resistor and into the base of our transistor. Next, we need a ground from the emitter of the transistor, and that goes to a ground pin. So that completes our transistor circuit. And you'll see that what I've done is I've made the yellow parts carrying the power to the LED, and then the 2 blue wires are what control the transistor. So now that we've built the circuit, we take it and put it onto the JackBord, and then we just do the usual: connect the ground to port D, connects the 3 volts, and then the 5 volts. We don't really need 5 volts, but it's just connected anyway. Okay, and that is our completed circuit. In this picture, we can see the first 3 yellow jumpers that we put in, and these connect the 3 volts through a 1K resistor via the LED, and then go to the collector of our transistor. In this picture, we've added the 2 blue wires, and these are the ones that connect from the 3 volts via a second 1K resistor, and then go to the base of the transistor in the center of the picture. And this is our completed circuit, and you can see that we've added the ground wire, the green ground jumper, from the emitter of our transistor down to the ground pin on the bottom of the picture. Now that we've finished building it, let's connect it to the JackBord, which we've done here. Now we just turn it on, and by default the LED will turn on, and that's because we've got the base connected to 3 volts. Now if I want to turn it off, I just remove the blue wire and the transistor turns off, and that's because there's no longer more than 0.6 of a volt on the base of the transistor. So to turn it back on again, I just plug it in. And likewise. So basically I'm using an electrical signal to control power going into the LED. The applications of this are enormous. This LED could be replaced by a big motor, a spotlight, an audio system, pretty much whatever you like, even turning power on and off to a phone. So this simple circuit is the basis for an awful lot of applications in real life. For more information, visit jb.works.